In last lecture we already studied about the 16th and 17th family, their introduction, their electronic configuration, their occurrence, and which elements are present in that family. That is the 16th oxygen family and 17th, that is the halogen family. Now we have to study the introduction, occurrence and electronic configuration of group 18 elements. This family or these elements are also called as the noble gases or inert gases. As the name suggests, they are very less reactive, that is totally not reactive. They are only form very rare compounds in a very drastic conditions. Now these noble gases are also called as the royal gases or inert gases, and these are the helium having atomic number 2, neon having atomic number 10, argon having atomic number 18, krypton having atomic number 36, xenon having atomic number 54, and radon having atomic number 86. Remember the atomic numbers of all these noble gases. All noble gases except this radon, because radon is the solid radioactive element. All the noble gases except radon occur in atmosphere. Radon is not in a gaseous state, remember that, though it is the inert element or noble element. The abundance of these all inert gases up to xenon is about 1% by volume in the air or atmosphere. Only 1% of these all inert gases except radon are found into the air, only 1%. And we can isolate these inert gases only and only from the air. Remember that. We can isolate the inert gases as helium, argon, krypton, xenon, etc. only if from the air. But the argon as the major constituent of the these inert gases, in all the inert gases, argon is the major. It found in more percentage than any other inert gases. And helium is found in natural gas also, in balloons for the, that is for we have, if we have to fly in the air, then we can sit under the balloon of the helium gas, and we can take the that is the happiness of flying as that of the birds in the air. So helium is isolated from the natural gas, and helium and neon are found in the minerals of the radioactive origin. That means radioactive origin means radioactive ores are there, such as pitchblende, monazite, cleavite, etc., in which we can found the helium and neon gases. Xenon and that is the radon. Xenon and radon. Rn means radon and Ra means radium. Remember that. Radium is the radioactive naturally found substance having very large mass number, about 226. And this radon are the rarest element in all the 18th family element. Radon and xenon are very rarest. But radon is the decay product of radium. You know the radium which is used in the watches or in the on the roads for the to show the diversion signs for the drivers, etc. Radon is very that is the radium is very useful element for, as the it is radioactive elements, and it always disintegrate alpha, beta and gamma rays from it, and due to that there is the light at very dark night also, and so the drivers of the automobiles or of the that is in any vehicle, it can found the way and the diversion if the radium is used for the showing the diversion signs. And electronic configuration of these elements are as shown on the blackboard. Now see, helium we use in the that is the square bracket for showing the condensed electronic configuration, but the configuration of helium is 1s2, and the configuration of neon having atomic number 10 is in square bracket helium, that is 2 electron, and then 2s2 2p6. So the general that is the outermost electronic configuration of this family is NH2 NP6, NH2 NP6. That means the last shell is completely filled having the octet, that is 8 electrons are completed, so they have no any reactivity to react with the other elements in the periodic table. They remains inert, but very few elements can react with these inert gases. There are some compounds also of these inert gases, but very rare compounds. Now argon having atomic number 18 have the electronic configuration as neon up to this 10, 3s2 3p6, that is the 18 electrons are there in argon. Krypton having the condensed electronic configuration as it is argon up to 18. Now from this d orbital started from the third main energy level, so 3d10 4s2 4p6. Now as you are seeing here, all the inert gases having the outermost configuration as in general NH2 NP6, and xenon having atomic number 54 have this condensed electronic configuration. Here 4d subshell is there and 5h2 5p6, and for radon 86 is the atomic number. Now up to xenon 54 electrons. Then here is the 4f orbital, now which contain the 14 electrons. Then 5d10 6h2 6p6. Now this is the electronic configuration. Now let us see the that is the properties of these families, that is electronegativity, electron gain enthalpy, atomic size, atomic radii. Let us see how the trends of them in for these families. Now see the atomic and ionic trends and in the physical properties of group elements of 16, 17 and 18. Now first property is the atomic and ionic radii. Now in 11th standard we already know that the atomic and ionic radii increases in the group from top to bottom. As the atomic number increases, new shells are added, and due to that new shells there is the increase in size of the atom and ionic radii from top to bottom. But the atomic and ionic radii decreases from left to right as we go into the periods, because as we go from left to right into the periods, what happened there? Atomic number increases, but electrons are added into the same shell, and due to that what happened? As the atomic charge or atomic number is greater but the shell is the same, there is no increase in the shell in the periods as we go from left to right. Then what happened? The nucleus attracts the outermost shells more effectively, and instead of increasing the size, the atomic and ionic size decreases. Now about the ionization enthalpy, see what happened. Ionization enthalpy, you know that it is the power to attract the shared electron pair towards itself, and as we go from top to bottom, as the atomic number increases, ionization enthalpy or ionization energy also increases due to the increase in the charge. Again, as we go in the period also, now as we go from top to bottom in the groups, ionization enthalpy decreases. Why? Because atomic and ionic radii increases. So the attraction of the nucleus the outermost electron decreases and ionization enthalpy decreases. Remember that in the group. But in period what happened? The shell is the same, but the nuclear charge increases, and due to that the attraction of the nucleus to the outermost electron increases, and therefore ionization enthalpy increases in the period from left to right. But still 15 group elements have the more large ionization enthalpy than the 16, because in 15 group elements what is there? In their corresponding period, the 15 group elements have the large ionization enthalpy than the 16 group elements period, because in 15 groups period the elements have the half filled orbitals which are extra stable, and due to that the ionization enthalpy, remember that in view region they may be asked, the ionization enthalpy of group 15 elements is greater than the group 16 element due to the half filled orbital of the group 15 elements, and due to that there is the extra stability.